Good. Now I can write name. I can have such variables. It's not preferred in research studies, but when we are collecting information for our own clinics, okay, we have to take people's names. So this is a string, okay, this is a string. So maybe that you want to their patients' problems, okay, maybe this can be problems is a string, okay, you want them to write what is the problem. So, or maybe any text, okay, string is any text. Maybe this is, or maybe allergic. If you don't group it, okay, allergic vegetables. Allergic vegetables, okay. So if you don't group it, this is a string, okay. For example, they are going to write tomatoes, potatoes, this kind of stuff. So these are string. Yes. Okay. So let us continue where we left. Here, okay. We have we define two variable names, okay, and this is data. Okay. Here what I am going to write. Look here. Sorry. I can change it as 1 and here 1 to 1. So you are not throwing this out of your. Do you have anything to say? I have said the microphone is open now. I pause. I just start recording. Yes, I start recording now. Okay. What was the meaning of 1 and 2? So here, look here. This symbol here converts label names, okay, these variable names, okay. So you click it, you see the value of the group, and here you see, you click once, you see the group, okay. So by the way, this one here is a nominal symbol, okay. This is also a nominal symbol, but there is a small difference. There's a small a. This means it's string, and here when there is no small a here, it is very little in fact to notice that there's small a here, there's not small a here. This is grouped. Okay, let us write an ordinal. Okay, country. Okay, so when we are going to group, we open values. We say 1 Turkey, for example, 2. Let us say Italy, okay, 3 France, okay, 3 countries. It's not important whether which one is which. Maybe that I can say 1 France, 2 Italy, and 3 Turkey. It's okay, okay. So I write countries here. Home country. Country. Maybe that they are living now in a different place, but these are their home country. Now I can leave blank spaces in label, but here I cannot leave. But there is something that let us write the countries. Now look here. I have zeros. There's something that I don't want when grouping. I don't want decimal numbers when grouping. So what I should do? I should have here 0, okay. And the width is 1. What is this width? This width is the number of digits that I am using here. Now here I am using 1 and 2. 1 and 2, only 2 numbers, okay? It's 1 digit number. I'm going to use 1 digit number. Okay, so here 1 0, and this is, sorry, this is not ordered. Since it is not ordered, it is again nominal. Since it is not ordered, this is again nominal. Now let us have one ordinal one. I can have education level. Okay, I can just write here education, and here I can write education level. I get education level. Okay, and here I can write 1 primary school. Okay, I can write to secondary school like there, secondary school. The order is important here. I cannot write one high school. It's not possible. 3 high school. And 4 university. I can write university. Or bachelor's level. I can write bachelor's level. Bachelor's degree. Yes. It's same as far as I know what I mean. Okay. So here again, I cannot have decimals. Okay. Because when grouping, I don't use decimals. We are going to see when we use decimals. I should have here 1, okay? Because why? Because I have 1, 2, I am going to use 1, 2, 3, 4, 1-digit numbers. Here, this width of this, what I am going to write here, okay? I am going to write 1-digit number. Now, for example, you don't throw this like that. This is just an example, okay? You ask people. By the way, this means first patient. Here, this is information for second patient. So each row gives us some information for patients, okay? Or if we are delivering a research study for our participants, okay? So here, this is 4th participant here. Okay, I write just 1. I can write 1 and 2 because no, I have how many countries? Let me look. I think 3. It was 3. Here I have 3 countries. Yes, so I can write 1, 2, 3. But you don't throw this out of my mind. Mind. So this means that let us interpret what means here. Okay, the patient, which is in the second row, is a 2. What was 2? Let us open it. Look, is a male from Italy, and its education is secondary school. Maybe that he is a child. Okay. So yes. Okay. I am continuing to record, and I'm going to continue to share my screen from here. I share my screen. He's still writing, but what? We'll see later. Okay. So I was here and here. Okay, explain this part. So what means here? The 7th one. Okay, this means that 7th patient is a female. Okay, is a female from Italy high school. Okay, you ask to your patients. Okay, and you record them. But this is just an example. That's why it's nothing reality. Okay, here. Yes, we are just learning now how to write and how to define. So education level, what is it? It's ordinal. It is in order. Now look at the symbol. You see this order? It is ordinal. You can here make it wider. Yes. And you can close it because sometimes it's easier to write just 1, 2, 3 instead of this information here. And we group it because we are going to use it in our frequency tables. Okay, we will see. Now, what else? We have nominals and we have ordinals. Let us have a scale. Okay, let us have a scale. Let us say that we need to know weight of the patient. Weight, okay? So this is numeric, okay? Now, this can be decimal. It's a continuous number and it can be decimal. Okay, so this is just an information, weight of the patient. Okay, so values. No. You don't group weight. Generally, you don't group weight or height or some measurements, some blood measurements. You leave it as scale because they can be very different, okay? There is a variety of different weights. It's hard to group all of them. So we leave it like that, and we say it's scale. Okay, so let us write. 8 digits seems a lot, but let us write here weights. Let us maybe 75.50. Let us some weights. Okay, I'm throwing again out of my mind. These are not reality. You know, I need some examples, so I am just making them. Okay, I'm just making them for this course. These are just examples. You must ask to the patients, but it took lots of time asking them. Yes. Okay, so what this means? This means that I have a female from Italy, high school, graduate, and it's 19.67 kilos, let us say. Okay, so here, do I need 8 digits? Let us think about this 8. What this 8 with 8 means. I'm going to write here. Okay. So weight, and I am going to upload you this document on module section. Weight and decimals. Let us talk about this decimals. Okay. So weight examples. Let us see how we should define these ones. Okay. Yes. Now, weight, okay, is the weight or width. Sorry, width. It is the width. It must be width here. Let me check. It's width. I was talking about weight, but it's width here. Width and decimals. Width. Yes, width and decimals. Okay, so width is the total. Okay, total number here. We don't count the dot. So width of this number here, width is 6. Okay, and decimal is the points after dot. So decimal is 3. Here, let us talk about width of this. Width is the total. How many numbers that we have here? We have 4 numbers, okay? 4 digits. We have 4 digits, width is 4, and decimal is the number of digits that we have after this dot. We have 2 digits here. So this is how we define it. Okay, I continue that. Yes, width is 6, decimal is 3. In the first one, because I have 6 numbers here and 3 after dot, and here width is 4. Okay, I have width is 4. This is how we define it. Okay, and decimal is 2. Okay, so let us look here. Width is let us count how many numbers we have here. We have 5 and 2, 7. Width is 7. And decimal is 2. Okay, this is how we count and how we define variables in SPSS. It is important to understand, okay, this is like a game, okay, for me, like a chess game. But if you know the rules, you can play. But if you don't know the rules, then you cannot play. So we have to know rules, we have to know how you can define it. You have to define it, how they are used. Okay? So here, let us look, I have, width is 4, okay? And decimal is 2. But I may have patients, let us have one more patients, above 100, okay? Above 100 kilos, let us say. This is 8. This is the 8. This is the 8, and this is female. What else I have? It's good. Okay. So this is also possible. Okay. So what I have to do now? What is the right thing to do? This is possible, but let us think about, is this possible? A person with this weight? No. So, is this possible? Maybe I have here more than 1 digit? No. Okay, yeah, so I have here 4 here and 2, 6. Can width be 6? Can a person be this weight? No, it's not possible. So, what is the maximum possibility that width can be? Width can be 5. Okay, the maximum possible, I write here the maximum possibility. Where is the weight? Yes, width. Okay, I have to change this to what? To 5. That's the correct representation. Now it is okay. Now about this, how many digits I need here? Okay, I say it is string, but I can have, okay, say, is it this possible? I can have how many patients I have? Maybe that I have 1,000 patients. It's possible. Okay, but if I don't have 10,000 patients, that is 10,000 is a lot, and I cannot deal with all of them. The maximum 10,000, and it's a lot again, but let us say it is like that. So we are going to think about how many letters or numbers we have here. Okay, the maximum possible. Okay, so 1, 2, 3, 4, 5, right? So what was I defined here? It automatically defined as 8. It's not wrong. I can say 5. I can say 5. This also looks smart. Okay, if I write 6, it's also okay. But if I write 12, it's nonsense. I have to write something close to it. Okay, so if it is 5, whatever it is, I have to define it like that, 5. Okay, this is just definition. Okay, if I define it like 1, let us see. If I say that width is 1, what will happen? Look. Did you notice what happened? Where are the numbers? They're gone. Because what I said that I have only 1 digit. Okay, either letter or a number. I have only 1 digit. So if I have only 1 digit, the program deleted me the second one. Because these were D1, D2, something like that. I write here 1, so it didn't accept the other one. So I write 2, let us see, I have to, it deleted and it didn't bring it. This is this, yes, so you can use this like that, but when it is like this is the true, wait, patient ID 5, patient ID, let us make it 2, and let us see, yes, okay, you see that it is okay. So this was nonsense, so if I write it by mistake, I can right click and I can clear it. Yes, so this is our SPSS program. Let us save it, and then we are going to have frequency tables. Okay, so how can I save it? I have 2 ways of saving it. One way is I save it as a data. The second thing is I save the output. I don't have an output now, okay? So I will not save output. I will save it and open it and then create an output. Output is when I make analysis. I will make it soon. I say save as, okay? And I am going to choose here, yes, okay, here, I just choose a folder and I am writing the name, demographic information. These are, by the way, are demographic information. Demographic. Yes, I save it as one. Demographic. Now I close it. Okay, I close it. Yes, I will. Now look here. Always when you are closing this program, second window comes to you, and it says, okay, do you want to save the output? Now I didn't do any output, I didn't do any analysis, therefore I say no. Okay, now I'm going to open it again. So what was the extension of it? So, okay, so it said somewhere here demographics, or I can search it from here sar.sav. Okay, let us search it from. Yes, you see it's sar.sav. My computer must be tired. Okay, sar.sav. Yes. Okay. So the extension is SAV. Okay. Every program has an extension. It's important to know the extensions to work with them. Okay. We need programs in all of our works. We cannot avoid them. The more that we know them, the better that we can do our job. So this is demographic SAV. This is what we were using. And I double click. It's a slow program. In fact, it takes time, a little bit time to open. You are seeing how it's opening now. It's opening. It's IBM Statistics version 25. We have version 26 now. Yes. Okay. Now let us calculate frequencies. Okay. So how? Analyze. Descriptive statistics and frequencies. So you have to know this way. So descriptive statistics is about defining data, okay, whether they are how many of them, and percentages, mean, median, mode, and maybe graphics. So describing them. This is describing in statistics. We are describing them. We are counting them. Okay. So here frequencies. So I'm going to count all of them. I select them. I send to the other part. Statistics. I'm going to do statistics. I'm going to find mean, median, mode. Can I? Now here I can only find mean, median, mode of scales. What is mean of mean? No. So I shouldn't choose this part here. I can only choose it with weight, because mean, okay, scales, numbers, we can find mean, median of numbers. So I choose nothing here. I just say continue. Okay, I choose nothing here. I just say continue, and I say okay. So look what I get. Now it counts me. Frequencies are counting. Okay, tables. That's our job. Now here missing, no missing values. I write all the information here. So I have no missing here. I have 8 patients here, but I write everything. Okay, no missing. So I have said I have 8 home country information, 8 education level information, 8 patient ID. So everything is 8. Now this is a frequency table. Okay. So in this frequency table we count them. Turkey 5. There are 5 patients from Turkey. There are 2 patients from Italy. There is 1 patient from France. Okay, we count them. These are percentages. So these are important for us. That's our job. Counting, finding percentages. But we are not going to count them by hand. We are going to learn how we can use programs to count them and what are their meaning, interpreting them. Yes, here education level. Yes, it gave me the statistics here. Their frequencies are numbers and percentages. You can see here also patient ID. Yes, there is 1 from each of them, and this is the percentage. Gender, yes, I have 5 females and 3 males. So grouping always works. That's why that we group, because we want to describe them, define them, and use tables, okay, and make it more visual. make our data more visual. Therefore, we are always grouping. If we can, yes. For example, weight of a patient. We can have a great variety of weights, so it's really hard to group them. But we can give intervals. For example, we can say patients between 70 and 80 kilograms. So it's possible we can give intervals. But again, it's up to our choice. What we need, really we are going to use that grouping. Sometimes we need to know the exact measurement. For example, when we have blood tests, instead of grouping, we want to know what is the reality, okay, or blood pressure. We need to know what is the exact measurement. Therefore, we need scales for defining exact measurements. Yes, and now what we say, how we do this? Once again, it's from analyze, describe statistics and frequencies. Okay, our statistical program draws us many tables in a minute. Okay, so let us count mean, median, mode. Okay, but I cannot count mean of country. I cannot count mean of education. I cannot count mean of patient ID. I cannot count mean of sex. Okay, I can only count mean of weight from here because it's scale. Mean, median, mode. Okay, and what we learned before, if they are equal, we say it's a normal distribution. If not, it's not a normal distribution. Okay, and it's really important in statistics because we decide which test we are going to use, whether it's a normal distribution or not. Yes, I choose the mean, median, mode. I can choose what is the minimum value, maximum if I have hundreds of data. Okay, I can choose minimum, maximum, and the other values for easiness. Yes, let us choose all of them. Okay, variance, I don't need it now. I say continue. So I choose some statistics here. I say continue. Now I am going to draw a chart also. The best way of knowing whether a distribution is normal or not is seeing its graphic. And here histograms. Okay, I can choose from histograms. This is show normal curve on histogram, and we decide according to this histogram whether it's left skipped, right skipped, or normal. I say continue. So here what I did, I go from analyze, descriptive statistics and frequencies. I choose weight here because it is the only one which is scale. Okay, I choose weight, and I choose from statistics these values here. I say continue. I go to charts. I choose histograms, normal curve, and I say okay, good. Yes, let us look what happened. Yes, this is what happened here. A graph, and let me see it takes a little time. Oh, okay. Yes, this is calculated here. You can see it. Mean, standard deviation, and no is here, but I said it. Yes, the other frequencies are here. Okay, I said okay. I asked the program to calculate mean, median, mode. You can see that they are not equal. So when they are not equal, distribution is not normal. Okay, and these are the other values that I asked the program to do. Now, what can I say with this graph? You can see that there is this line goes a little bit here. So this means that this is right skewed. Okay, it goes to the right. We say it is right skewed. It's not a normal distribution. It is right skewed. We have some outliers here. And yes, we are going to stop here.